We made it. This is it. Last lecture. Wait, I need that to be louder. All right. I would like to think that maybe this is the last lecture that I will ever record, but probably not. So let's get right into it. So picking up with this Jablonski diagram activity, so in case you practice this, so I'll just tell you what everything should be. So 2A, here you can see, goes from a singlet state into a triplet state. But all the same, that 2A is going to be stimulated absorption. So I'll just say stimulated absorption. Okay. Oh, I forgot. Why did I start with 2A? That's hilarious. 1A. Let's start with 1A. So that is still stimulated absorption from a singlet state to a singlet state. Okay. And then now 1B, you can see, is going to be fluorescence. Okay, because it's going singlet state to singlet state, but now the emission is a smaller energy than the excitation. Okay, so 1C is internal conversion. So it's going from a non-radiative transition, and the way we know it's non-radiative is because it's vertical on this line, or excuse me, horizontal. So it's not changing energy. So that is, I'll say, internal conversion. 1D, you can see, is another non-radiative process. However, because it's going from a singlet to a triplet, that's got to be inter-systems crossing. Okay. And so then we have 1E. Oh, and excuse me, 1E corresponds to this, and 2B corresponds to this. So 1E is just simply non-radiative transition of energy. Okay. So now 2A, that one is also stimulated absorption. 2B right here, that's going to be phosphorescence. Because it's going from a triplet back down to a singlet, and the emission energy is less than the excitation energy. 2C is another non-radiative transfer, and you can see that that's also going to be intersystems crossing, going from the triplet state to the singlet state. Okay. Okay, so moving on, let's get into